Boss fights. They can be really important parts of a game, but where do you even begin if you're trying to design them? In this video, I'll go over how I approach them in my game, how I came up with the boss designs and animated them, how I coded the attacks and their sequencing, and how I optimized them. My name's Graham, I'm the developer of ZOE Begone, which recently released on Steam and consoles. It's an arcade style shoot 'em up with a 1930s drawn on film animation style. You play as Zoe and take on the animator as they try to destroy you with their paintbrush and other tools. I had never programmed before this project, so some of the code examples coming up are quite old and probably not the most efficient or elegant ways to do things, but it's what worked for me and made sense to me at the time. So I decided quite early on that each boss in Zoe would be one of the tools of the animator. And the first thing I did for each boss was to sketch out a few ideas for their attacks. They're really quick sketches that I do just to get the basic ideas on paper, so I can then dive straight into making them. The sprites for all the bosses started off as photos of actual objects that I have, which I then took into Photoshop to stylize slightly so they'd fit the feel of the game. So this knife sprite has the main layer, its shadow, a highlight for the blade that flashes during its intro animation, a version of the main sprite that's coloured differently for one of the attacks, and a silhouette layer that's used in the death animation. All the animation is done with code for the bosses, so these still frames were all that was needed. Each boss fight starts with the camera locking into place and zooming out, so the play area then becomes a single screen arena. I did this because it would have been a bit of a nightmare to design a boss fight where the player could just run away at any point, but it ended up helping to mix the gameplay style up a bit as well. So the camera for the main game is set up with the view and projection matrix functions like this. This setup allowed me to zoom in and out by adjusting the width and height arguments, and I set up some presets for different zoom levels that multiply the width and height values. So the higher the value, the more zoomed out the camera would be. Then changing the values of W zoom 2 and H zoom 2 to those presets would adjust the target values for W zoom and H zoom, and this formula would take care of animating them smoothly into place. I'll explain that formula in a bit more detail later. So to zoom the camera in and out, all I had to do was change those target values wherever the triggering events occurred. I used camera zooms and slight rotations as well for some other subtle effects on certain player actions. All with this same system, just changing those two variables, width and height, in the camera object by switching their corresponding target variables when certain events were triggered by the player. During the levels, the camera would normally lock to the player's X position, but when frozen for the boss fight, it would stay in place at X plus freeze, which was triggered when the camera zooms out for the boss fight. I also needed to spawn some walls with this script to keep the player within the frame. Okay, so once the camera's pulled out for the boss fight, a really simple animation of the shadow of the boss crossing the screen plays out, while the boss health bar fills up from 0 to its current value. I used a global variable for the boss health because they also appear throughout the level, and I wanted any damage they took then to carry over into the actual boss fight. Each attack type is set up as a separate object in GameMaker that gets spawned in a sequence from the boss controller object. Then each attack would initially involve the knife animating onto screen to its starting position, making contact with the film surface for a set length of time where it would perform its attack, and then the attack would end with the knife pulling up and going off screen again. The player could only deal damage to the boss while it's in contact with the surface, so the animation had to be pretty clear to communicate that transition. Most of the knife animation involves moving the sprite from point to point using the formula I mentioned earlier to ease it into place. At the start of each attack, I'd spawn the knife off screen and then set the X pos 2 and Y pos 2 variables to where I want it to move, while also setting an alarm to trigger the next change. So the formula is basically calculating the difference between two values, dividing that by a certain amount, then adding the result back to the first value, so the difference between them is reduced. Then that difference keeps reducing each step, and in this case eases the exposition of the sprite into place. I know this is pretty much the same as using the lerp function, but for some reason I found this more intuitive to use at the time. The formula can be applied to any other values to add detail to the animation. I used it for the image angle, X and Y scales, and animated the shadow to give it a better sense of place in the scene. It's pretty simple in terms of animation, but I wanted the boss objects to feel pretty solid and grounded to contrast with the animations of the rest of the game, so there was no need to do anything more complicated. From there I could focus on the actual attacks, whether it be spawning a bullet pattern for the player to dodge, other enemies, or just a whole bunch of knives trying to stab you. So once I had 3 or 4 attack objects done for a boss, I could start coding how they would be sequenced. I used a controller object for each boss to deal with their intro animations and the timing of their sequences. Each attack object is assigned to a variable in the create event, and then an array is created for the sequence so it can be cycled through with a current attack variable. When an attack object has finished its attack, it sets off an alarm in the boss controller, which then triggers the can spawn next attack variable. The current attack variable then increments or loops back around to 0 before spawning the next attack in the sequence. This system allowed me to easily swap the order of attacks around or to randomize some elements of their order. As you can see from some of these boss attacks, I was spawning quite a lot of bullets, and I was initially just using the instance create layer and instance destroy functions. Much later on in development though, I realized this was causing some performance issues in some of the builds, so I needed to try and optimize the bullet spawning with an object pooling system. So the idea of an object pool is to create a DS stack of deactivated instances of an object that you can then take from when needed, reactivating the object instead of instantiating it, and deactivating it and adding it back to the stack instead of destroying it. A DS stack is a data structure that works a bit like a stack of coins. When you push something to it, it goes to the top of the stack, and when you pop something from it, you take it from the top. This is also known as a last in, first out data structure. I used a separate object to manage the pooling system, so in its create event I started by creating a DS stack that the bullet instances could be added to or taken from later on. Then when I spawn a bullet, I'd check if the relevant DS stack has any entries on it, and if it doesn't, I'd just use the normal instance create layer function to spawn a bullet like I normally would. If there is a bullet object in the DS stack, I'd use DS stack pop to grab it and assign it to a variable, then use instance activate object to reactivate it, and then change its X and Y values to move it to its spawn point. Then where I'd normally destroy the bullet, such as on an alarm or collision, I push it back to the DS stack instead with DS stack push, reset any variables that I need to for its next activation, and then deactivate it with instance deactivate object so that it's just waiting in the pool and ready to be popped and reactivated when it's next needed. I also primed the pool to minimize the use of instance create for the first time a new instance of the bullet is needed during the fight by creating and deactivating a bunch of instances of the bullet at the start of the level. If there was a slight performance stutter here, it didn't matter so much and hopefully wouldn't be noticeable. You also need to destroy any DS stacks when they're not needed, such as the destroy event of the object that's managing the pools. That's pretty much the whole process I would go through for each boss fight. Of course they all needed a satisfying death animation too, but I really just used the same techniques, spawning different frame sequences and moving, rotating and scaling objects around the screen with the easing formula.